Hi. So look at question number 11. And question 11 says ABCD is a regular tetrahedron. P and Q are midpoints of edges AC and AB respectively. G is the centroid of the face BCD. And theta is the angle between vectors PG and DQ. So now we have to understand a few options. One of them is the first thing that we have to answer basically is the angle between vector AB and CD. Angle between these two vectors, right? So we will use the properties of regular tetrahedrons, and what we will see here is, let's consider a tetrahedron ABCD with D being the origin. Let's say D is my origin and A, B, C are the other vertices of the tetrahedron, right? So if D is my origin, then A vector, let's call it A vector, and this is B vector, and this is C vector, right? So dA vector, what is dA vector? Let's think about that. dA vector is simply A vector because D is the origin, and dB is B vector and DC is C vector. Similarly, if dA is A vector, AD vector will be minus A. And what is BC vector? BC vector will be simply C minus B, right? So let's find out what is the angle between AD and BC. Because if we know angle between AD line and BC line, since it is a regular tetrahedron, that should be the same angle between AB line and CD line. You can notice the symmetry. AB line is this line, CD line is this line, right? So angle between CD and AB is the same as the angle between DA and BC. Follow these dots. The dotted lines are the required angle between these two lines, and you have the darkened lines. Those are the angles that we will actually find, right? So that is fairly straightforward. Both of them are equal angles because it's a regular tetrahedron. So there is a symmetry across all of these angles. So if we do AD dot BC, right? AD dot BC simply becomes minus A dot C minus B, which is equal to minus A dot C plus A dot B. Now think about what is A dot C and A dot B. A dot C is this dot product, A and C vector, the dot product here. So that will be minus mod A mod C cos 60, because we know that all of these are equilateral triangles. That is a property of the regular tetrahedron, that each face is in itself an equilateral triangle. And there are 4 such equilateral triangles here. And therefore mod A, mod C are same. This is same. And similarly, mod A, mod B, and cos 60 is this dot product. And this turns out to be 0. We get AD dot BC is 0, which means AD is perpendicular to BC. AD is perpendicular to BC. And similarly, AB will be perpendicular to CD. So option A will be correct. Option A is saying that the angle between AB and CD is 90 degrees. Now the other part of the question is basically finding the angle between PG and DQ. It's quite straightforward. It's just that you have to work out what is PG vector and what is DQ vector. Before you can do that, you need the position vector of G and position vector of P. Now P, let's write P's position vector. P's position vector is simply midpoint of edge AC. A and C position vectors are A and C, so P is A plus C by 2. And what is G? G is centroid of BCD. BCD, B vector's position is B, and C and D is origin. So centroid will be B plus C plus origin by 3. So P and G position vectors we have found. So therefore PG vector will be G vector minus P vector. So PG vector will come out to be the difference between B plus C by 3 minus A plus C by 2. When you do the calculations, it becomes minus 1 by 6, 3A plus C minus 2B. And similarly, you can find out DQ also. So let's find out our D vector. D vector is obvious. D vector is origin. And Q vector is the midpoint of A and B. So it is A plus B by 2. So therefore, DQ vector simply becomes A plus B by 2. Right? Now, to find the actual angle between them, I have to take the dot product between PG and DQ. So you will do PG dot product with DQ. And that will become mod of PG, mod of DQ, and cos of the angle between them, right? Cos of theta, where theta is the angle between PG and DQ, right? Okay. So let's just do the dot product. This is the theta that you want. So finding the value of the dot product will give you the answer. So basically cos theta can be PG dot DQ by mod PG mod DQ, right? Great. So this is DQ. So what is PG dot DQ? PG dot DQ is pretty straightforward. That will be minus 1 by 6 3a plus c minus 2b dot product with a plus b by 2. So that becomes minus 1 by 12. You have 3 mod a square plus 3a dot b plus 3a dot b plus a dot c plus b dot c minus 2a dot b minus 2 mod b square, right? This is what you are getting. Now, since it is a regular tetrahedron, let's take mod a is equal to mod b is equal to mod c is equal to k. The length of each edge is same. So we get here 3k square plus 3k square. Cos 60 is the angle between a and b. So half plus k square and half a and c, cos 60 again, plus k square and half again cos 60 minus 2k square into half minus 2k square. So this is the expression that we are getting here, minus 1 by 12 of this. So let's evaluate this. This is k square by 2, k square by 2 becomes k square, and this is minus k square. So this cancels these two, and you have 3 by 2 k square. This 3k square and this k square becomes k square plus 3 by 2 k square. So you have 5 by 2 k square, right? So it becomes minus 5k square by 24. That is my PG dot DQ value. Now you just have to find out the mod PG and mod DQ. How do you find mod PG? Mod PG will simply be PG dot PG. Mod PG whole square is PG dot PG. If you do that calculation, it will come out to be 1 by 36 9 mod a square plus mod c square plus 4 mod b square plus 6 a dot c minus 12 a dot b minus 4 b dot c. So do the calculations in the same way like we did here, and what you get here at the end of all of these calculations, which I'll not show here, will be 9k square by 36, which is k square by 4. You get this, and similarly you get dq square. Mod dq square will come out to be 3k square by 4. In the same way, how will you do mod dq square? dq dot dq. So 3k square by 4. Therefore, pg mod pg is equal to k by 2 and mod dq is equal to root 3k by 2, right? So our cos theta will become the division of pg by dq by mod pg mod dq, and that is equal to divided by k by 2 and root 3k by 2. So you get 4 here, so you get 6 here. Okay, so 6 here, and k square cancels. So you get minus 5 by 6 root 3 is your cos theta. If cos theta is equal to minus 5 by 6 root 3, that means it is an obtuse angle. So what we can say is that the actual angle will be pi minus cos inverse 5 by 6 root 3. Pi minus cos inverse 5 by 6 root 3, because this angle will actually be obtuse. So if you had an acute angle of 5 by 6 root 3, cos inverse 5 by 6 root 3, the real angle that you care about is 180 minus that. So this is the answer, and this is option C. So this was a fairly easy question. I'm sure that you guys must have understood this. I'll see you next time.